Hi. After learning about DC motor construction, working principle, EMF, and torque equations, now it's time to know about how speed can be controlled in DC motor. So this video tells about the speed control of DC motors by various techniques. Let us go through it. Speed control. So basing on the equation, so N is equal to V minus IARA divided by K phi. Basing on this equation, so this equation comes from back EMF and the other torque equations. So we have two kinds of control of the speed, which is armature controlled and field control methods. So here armature IA can be controlled, and also by controlling the flux phi, flux phi, so the field control method can be obtained. So that is how the DC motor speed can be controlled. Whenever you want to control the speed of the DC motor, it has to be connected in a shunt way. What is this shunt? Connecting field windings in parallel. So here, as I said you, there are two methods. One is armature control method and the other one is field control method or field flux control methods. So if you look at this figure, so you have the armature A, and you have the field F, and also you have a variable resistance connected to the field winding. The resistance can vary from 0 to its maximum value. Basing on that, the field current changes. Whenever the field current changes, flux also changes. So if you go to the previous equation, so I am varying the flux phi here. So speed is inversely proportional to the flux. When the flux changes, the speed is going to vary accordingly. When the flux is low, then the speed is going to be high. When the flux is high, speed is going to be low. So that's how the speed control can be achieved by this field control method or flux control method actually. Now coming to the next control method called armature control method. The field winding doesn't have resistance as like the previous circuit, but the armature has a resistance, a variable resistance, where the resistance can be varied from a certain value to very high value. It can be varied. So by varying this resistance, I'm controlling the current passing through the armature. You can see I can control, I can do the current passing to the armature is being controlled here. So whenever, so basing on that, we can do the speed control methods. In field flux control methods, we can go around the rated value of the speed, and then control this motor, DC shunt motor. But when you come to armature control method, we can operate below the rated speed of the DC motor. That's how we can do these control methods. Now we'll come to the characteristics of the DC motor. There are mainly three characteristics of the DC motor. So torque, armature current characteristics, speed, armature current characteristics, and speed torque characteristics. So you can see the first one, torque versus armature current characteristics, and speed and armature current characteristics basing on the flux, and speed torque characteristics, which we are going to find out. Basing on these three relations, they are going to be done. So if you can look at the picture, so torque IA characteristics, based on the torque and IA equation, it is a linear straight line passing through the origin. And speed IA characteristics, it has to be a straight line. Basically, high speed will be there at zero armature current, and the speed, whenever the armature current increases, the speed remains constant. That should be your ideal value. But practically, because of some effects, because of inertia or something, this value is going to be like this. And based on the third equation, speed torque characteristics, which we call, it should be a straight line. But because because DC shunt motor, speed torque characteristics is a constant value, approximately constant value. That is the major advantage of your shunt motor. So it would be a slanting line like this. So these are the three characteristics. So whenever characteristics is being drawn, whenever characteristics is being asked, you have to draw the graph actually. So in this presentation, we spoke about three things. One is control methodology, which is armature control method, and field control method. The other one which we have studied is characteristics of DC motor. So characteristics of DC motors follows these three equations. Basing on these three equations, we get these three graphs actually. These are the three graphs which are called as the characteristics of either DC motor or DC shunt motor. Basically, in BW, mostly we talk about DC shunt motor rather than other kinds of motors called series motor or compound motor. So here, these characteristics, whenever characteristics is being asked, you have to talk about these relations, and also you have to draw the graphs and explain how these graphs has come. With that, I convey thanks to you. Hope with this video, all the DC motor part has been over. And now we continue with the next topic of your BW of the machines, which is actually three-phase induction motor. So thank you all of you.